Okay, let's begin. So some guys ask me the question about finding the maximum and minimum of a trigonometric function. For example, we have the function like this: y equal to 4 times sine of 2x plus 3. First, tell me what is the maximum of the sine of 2x? What is the maximum for this guy? 1 or 2? 1 or 2? The maximum? 1, right? Not the 2. So we know the maximum of the sine x is equal to 1, right? For this guy, the maximum is equal to 1. And for y equal to sine of 2x, the maximum still equal to 1, right? So this guy, its maximum is not equal to 2, still equal to 1. Therefore, the maximum for this given function, okay, for this guy, that should be equal to 4 times 1 and then plus 3, which is equal to 7. Okay, so this is how we find the maximum of this trigonometric function. So in the section 3, we have learned the graphs of the sine and cosine functions. And in the section 1 and section 2, we learned the sine and cosine function and their properties. So right now in the section 4, we'll talk about the other 4 trigonometric functions and their graphs. So totally, we have the 6 trigonometric functions, but now we have learned 2, sine and cosine. So let's recall how we define the sine and cosine. Okay, so to define the sine and cosine, we first begin with an angle in the standard position, and this angle alpha, right? And its terminal side intersects this unit circle at the point x and y. Then we may just use the x-coordinate of this point to be the cosine alpha and the y-coordinate as the sine alpha. So right now, we will still use this graph to define the other 4 trigonometric functions. So first, let's define the tangent. Tangent alpha is defined as the ratio of the y and x. So it's y over x. Here, suppose x is not equal to 0. If x is equal to 0, then tangent alpha is not well defined. And then we define another trigonometric function, cotangent alpha. This is defined as the x over y. Here we need the y not equal to 0. So this is the 4th trigonometric function. Then let's go to the 5th. So we have the secant alpha, which is defined as the 1 over x. And here x is not equal to 0. Then the last one, cosecant alpha, which is defined as the 1 over y. Y is not equal to 0. Okay. So let's recall sine alpha is equal to y and cosine alpha is equal to x. Okay. So by now we have defined the 6 trigonometric functions for an angle in the standard position. And here the x and the y is the coordinates of the point of intersection of the terminal side of this angle with the unit circle. And from these definitions, we can immediately get some identities which are called the identities from the definitions. So first, we know tangent alpha, which is equal to y over x, and y is sine alpha, and x is cosine alpha. So tangent alpha is equal to sine alpha over cosine alpha, provided the denominator cosine alpha is not equal to 0. Okay. And here cotangent alpha, which is equal to x over y, we just replace x by cosine alpha and y by sine alpha. Then we get cotangent alpha is equal to cosine alpha over sine alpha. And then you have the secant alpha, which is equal to 1 over x. So x is equal to cosine alpha. So cosine, okay, the secant alpha is equal to 1 over cosine alpha. Then the last one, cosecant alpha is equal to 1 over y, and y is equal to sine alpha. So cosecant alpha is equal to 1 over sine alpha. And this identity holds provided no denominator is equal to 0. Okay, so here cosine alpha not equal to 0, sine alpha not equal to 0, then these two identities holds. Similarly for the secant and the cosecant alpha. Now, when we have a new functions, the first thing we need to study is the domain of this function. We want to know the set of the inputs for which this function is well defined. So let's first look at the domain of the tangent alpha. We know this tangent alpha is well defined if this denominator is not equal to 0. So that means the cosine alpha is not equal to 0. Let's see when the cosine alpha is equal to 0. So cosine alpha is equal to 0 if and only if this x coordinate is equal to 0. Right? Now let's look at the graph. So you look at this graph, let's see when the x coordinate of this point of intersection is equal to 0. So x equal to 0 means this point is on the y-axis. Either you have this point, right, or you have this point for which the x coordinate is equal to 0. So if this point, then this angle should be the half pi plus the multiple of 2 pi, right? If this point, then the angle should be the 3 pi over 2 plus the multiple of the 2 pi. Or you may say first, you may have the half pi, and then this 3 pi over 2 is equal to half pi plus pi. Let me write this here. So this guy, here we have the half pi, and here we have the 3 pi over 2, and this can be written as the half pi plus pi. And if you rotate 1 volt revolution, then you will have the half pi plus 2 pi, right? And then one more revolution, you have the half pi plus pi and plus 2 pi.